So we are having a Spacelink webinar. We are running this webinar, just like Mr. Hobbs said at the beginning, to give you access to the amazing Eve North, who we're going to chat to about her favourite topic in space at the moment. And then we're going to go in to talk to her about her career. And anything else you want to ask her. You've got 45 minutes to completely pick her brains. Now, how it's going to work is I'm going to start by asking her 2 questions so we can get to know her a little bit. Then she's going to do a talk of Andromeda and show us around that galaxy. And then it's an absolute free-for-all for you to ask questions about her, Andromeda, etc., etc. Right, so welcome, Eve.
Hello.
Hello. Sorry, there's lots of talking from me. So start us off. Tell us, you've got, I think, oh, your school Plascock, let us know how many students you've got. Mr. Hobbs has got about 120. So please, would you let them all know what it is that you do?
Well, hello students. I'm Eve and I'm a PhD student at Cardiff University. So this means that I'm doing sort of, instead of like you guys, you get taught by Mr. Hobbs or your other teachers in North Wales, I think it is.
Yeah.
And they talk at you and then you do activities. I'm basically doing the activity bit all the time. So I'm just doing research. I sit there on my computer, I get data from a telescope in Chile, and I, in a general sense, kind of poke it and see what I can find out. So most of my research at the moment is measuring supermassive black hole masses. So as I'll show you in my talk in a bit, my favorite thing is galaxies. I think they're amazing.
What's not to love about galaxies?
It's really nerdy, but hey ho, that's life. And so I'm sort of looking at the very centers of galaxies, and I'll show you kind of how a supermassive black hole, where it resides.
Or what do you mean by resides?
So sorry, where it lives.
Where it lives.
Where it lives.
So
yeah.
Supermassive, not just black holes, supermassive black holes.
Yes. So these are very, very old objects that have sort of been sat around the universe for, well, since very, very, very early in the universe, we think. And yeah, they sit there and stars and gas kind of orbit them.
Because they're so big?
Yes.
Okay,
so big.
Great. So that's what you're doing now. That's at Cardiff University, isn't it? So how did you get into science? What made you think, I know what I want to do, I want to study supermassive black holes? What made you do that?
So my dad is a biologist, so I think I always had that kind of interest in science. And then it was, I guess, when I was about your age, a little bit older, I started kind of looking up at the stars and finding them really interesting, looking at the constellations, looking at what else you can see beyond the stars. So you can kind of see the Andromeda Galaxy, which I'll show you later, and the Milky Way galaxy that we're in.
You can see the Andromeda Galaxy just with a normal telescope?
Yes.
Oh,
yes.
wow, okay.
If it's really dark with your own eyes.
Oh gosh, okay.
Big, yes.
Well, definitely from this webinar then, I want to discuss which way I should look tonight. Okay. So you just were fascinated by it from about 10 years old?
Yes. And then I kind of found that I seemed okay at maths and physics at school. So I was like, yeah, I think I can do this as a career. And yeah, so yes.
Okay, excellent. Right, so I won't take any questions just yet. I'm going to go straight into talking about Andromeda, and then after that, I'll absolutely open the floor to ask any questions to Eve. Right, let me just share the screen with you for her pictures. Okie dokie, and put them on full screen. Right, Mr. Hobbs, can you see the pictures?
Yes, we can.
The other school, if you could just say a yes for me, or you're just going to put it back to beginning. Okay, so, oh, thank you. Let me just have a look. Yes. Oh, and there's 35 of you. Hello, guys. Right. So, over to you.
Okay, wonderful. So as I said, galaxies are kind of my favorite thing. I quite like the large scale structure. So some of my colleagues look at kind of small scale things, which we'll go into today, but I prefer the bigger things within the universe. So we're going on a tour of Andromeda. This is my spaceship. It's very shiny because, you know, why not? I like shiny things. So this is Andromeda. So this is a picture taken I think just with a normal telescope, this is the kind of detail that you can get. And what you can see is it's kind of a flat disc with kind of a bulgy center, a bit like kind of two fried eggs put back to back. So you've got the bulge in the center and that around the outside. What you can also see is bottom right of the main sort of disk of the galaxy, you can see another tiny kind of fuzzy blob. And that is one of the dwarf galaxies that orbits around Andromeda. So yeah, around Andromeda, there are many, many kind of tiny galaxies that orbit it and will eventually kind of fall onto Andromeda and become part of the main galaxy. So what we'll do for our tour is we'll start around the outside in the dwarf galaxy area. So as I said, around Andromeda, there are many dwarf galaxies. They've got their own little kind of dust clouds and stars within them and solar systems as well, so potential planets and things. And what you also have around the outside of galaxies, more towards that bulge, bright center, is globular clusters, which sounds like a very fancy name. It's basically just big star clusters. They're very old. They're kind of one of the first things that sort of forms within the galaxy. And they're just very old groups of stars that orbit each other, but also orbit around or revolve around the main galaxy.
You said they're globular.
Yes, yes.
Globular or globular?
Globular.
Globular. Okay,
it's a bit of a mouthful, and it's it's just a fancy name for star cluster.
Yeah, I like it. I've got a new word.
Yeah, it's a good one. So if we move a bit more into this main disk of the galaxy, so if I flick back actually to the main disk, what you can see is that main disk is quite blue. It's kind of got some darker lanes in it, but a lot of it is just mostly blue, quite bright stars. And those tend to be very new stars. They're quite big. So like the thing on the left of the screen, the blue giant. So that's a star that's a lot bigger than the sun. It's a lot younger than the sun, and it's also hotter than the sun. So they're bigger, younger, hotter, and that's kind of what it makes up most of the disk. What also makes up that main disk is main sequence stars like the sun. So these are kind of like middle-aged, very average stars.
So you're saying our star is average compared to all the stars in the galaxy?
Yes.
I'm not taking it, but yeah.
Kind of worried, but yes.
But as in size and shape and heat, it's pretty average.
Yes.
And then you've got the massive blue giant.
Yes.
Okay.
Yes.
Cool.
Yes. So the kind of outer disk of the galaxy tends to be younger stars, like our sun, which is relatively young, but about halfway through its life. And what you also get in the outer disk a lot of, because it's quite relaxed out there. There's not too much radiation or anything. So what you get is you also get exoplanets. So this is a kind of artist's impression of what one might look like. So this is a very gaseous planet on the left that's orbiting very close to its star, so it's very hot. Wouldn't be very good for life because you potentially get boiled alive.
Yeah.
And then frozen at night time. It would be very extreme. So as I say, in the disk you get a lot of new young stars, and you get a lot of planets as well. So this is our hot Jupiter. So you can see that because of kind of how close it is to the star, a lot of its gas is getting ripped off. But generally it's very hot. It will have quite short years because it will orbit very close and very fast around its star. But yes, that wouldn't be so suitable for life because it is so hot.
How short is short? Couple of days? Or?
Yes.
Yeah.
Yes.
So it would be a birthday every couple of days.
Yeah.
Right?
Yeah.
Okay.
It should be quite extreme, but whipping around very, very fast. So if we go on to the next slide, yes. So what you saw in Andromeda, in that big blue disk there, was you also saw some very dark lanes. And those are dust lanes. So they're kind of concentrations of very small particles that are kind of like sand or soot. They're made of the same thing. So they're made of carbon or kind of glassy bits. And those are kind of where particles within or molecules within the gas kind of freeze out into these dust particles. And what they do is they absorb starlight, which is why we see them as dark lanes within the galaxy. So they kind of block out the starlight that we would normally be seeing. And one of the big problems is that baby stars tend to be formed within those clouds of kind of dust and gas. So we can't actually see where baby stars are forming in the optical because all the light is being absorbed by the dust particles. So what we do to try and get around this is dust happens to re-emit the starlight that it absorbs at slightly longer wavelengths. So it
right, let's hang on there.
which is going.
So the dust is absorbing all the light, and then what did you say? So it's re-emitting.
Yeah. So it then gives off heat.
Right. So the light is absorbed.
Yeah.
And it gives that off as heat.
Yes.
Yeah. Which we can see.
Yes.
Right.
So what we can do is, we can send a telescope into space, and that looks at the heat within the universe. And yes, if I go on to the next slide, this is what Andromeda looks like if you look at the heat that's being emitted. So you can see, if we kind of compared it with the earlier image, the bright bits of heat are where the dark bits were earlier.
We wouldn't, because I am going to look for Andromeda tonight, I wouldn't see this because this is, I'd need infrared
eyes.
Yeah.
Yes, you need eyes that see thermal heat. Yes, so this is what happens, I say, when we look at the heat. So we can see all these kind of tiny bright spots within the orange. Those are where stars are being formed.
Baby stars.
Yes, so they're all the baby stars and all the baby kind of solar systems that you might be getting in Andromeda, all the young stuff, and those will probably be potentially more the blue giant size of stars. They'll be a bit bigger than the sun, but there will also be sun-sized stars and things like that. So
okay,
yes, that is Andromeda. And what you can also see in this image is you can see the blue points of light all across the image, and that is looking at the X-rays that are being emitted. So as I mentioned earlier, there are supermassive black holes. Those emit X-rays. So because they've got more, they're higher energy, because they've got bigger gravity. They've got higher energy stuff going on around them. They emit X-rays, which are
so
higher
all
energy.
Those blue dots are black holes.
Yes.
I never knew there were so many.
Yeah, there's a lot.
It's a lot.
It's weird. Yeah, and you think, oh, but no, yeah, it's probably safe.
Okay.
But yes, so all those tiny blue dots will be black holes that are emitting X-rays, which, you could do an X-ray of your hand with those if you wanted to. Okie dokie. So what we'll now do on our tour is we'll move slightly more towards the centre of the galaxy and into that brighter, more orangey bulge of Andromeda. And that tends to be slightly older stars. So kind of hoping you might have heard of the constellation of Orion in the night sky, the big hunter.
Have. Yeah.
Okay. And in the top left, there's a quite famous star called Betelgeuse. Lovely, wonderful. And that, if you look at it kind of carefully, you can see that it's more orange than your standard star in the night sky. And that's because it's a red giant. So it's a very old star, and it's kind of, in its old age, it's puffed up. So the surface is a bit cooler than the sun, but the centre is a lot hotter. So the outer layers kind of puff up. And that's what you're seeing on your screen here, is a very old, large Betelgeuse. And so the bulge of Andromeda is kind of full of these stars, which is why it looks orange in the image, because they're all the old stars they've kind of circled in, and yeah, that's the old people's home, basically.
Right.
Centre of Andromeda. Yes. So these are coming to the end of their life, and fingers crossed Betelgeuse will do this very soon, we kind of hope, is that at the end of their life, big stars, not our sun isn't quite big enough to do it, but big stars like Betelgeuse will eventually explode into a supernova. So they kind of, they just get too old, collapse in on themselves and explode outwards. And this image that I'm showing you here is the Crab Nebula, which again, with a normal telescope, you can kind of see a definite fuzzy patch within that.
So the Crab Nebula, is that in Andromeda, in that
that's actually, I'm cheating, that's in the Milky Way,
right,
in our galaxy, but there will be ones very similar
making
in Andromeda.
up that disk.
Yes.
Okay.
Yeah, making up that.
So exploded old stars.
Yes, so you can see kind of that web of sort of old innards of the star, basically, and at the centre there'll be a very dense, probably a black hole, maybe a neutron star.
Okay.
And there'll be a very dense object. So that's, so in that bulge you'll find very old stars, but also a lot of these supernova remnants. the leftovers of those explosions. Yes, and as I said, we hope that Betelgeuse will do this very soon. Because it's slightly closer, we'll be able to get a really good view of a star exploding like this, to really see what's going on. Because we think that our solar system is sort of has formed within one of these supernova remnants.
Yeah, right. Cool.
Yeah, because we're here and we've got like gold and things like that. So we know that something big has happened.
Yeah.
A big explosion. Yes. So, as I mentioned earlier, yes, we can see a lot of X-rays coming out of Andromeda. So this is a picture using an X-ray telescope of Andromeda. And as you can see, you can't really see much, just a load of point sources. So a load of,
keep going.
Sorry. Yeah, just a load of dots that are about the image. And each of those dots is going to be a black hole. And what you can see is they get brighter as you go towards the center. And so at the center, there's a very bright source of X-rays, and that is your supermassive black hole. So as things orbit this black hole, because it's so dense and therefore has such a huge gravitational pull, they get very fast and they start emitting X-rays. The X-rays are kind of like the friction burns from gas rubbing against gas, because as it's falling in, it's kind of rubbing against itself and it gives itself a big friction burn and emits X-rays. Weird.
Okay, so a black hole, things orbit around it, and then as it gets sucked in, there's like a crash which throws out an X-ray, which we can see.
Yes.
Okay.
Yes.
I'm with you. Yeah.
Yes. And yes, as you can see, Andromeda has a lot of black holes, which is awesome. And what you'll also get with the with the supermassive black hole, because it's so big, some of the things when they come in and try and sort of fall onto that black hole in that crash, as well as emitting a lot of X-rays, some of the gas gets sort of shot out the top and the bottom of the black hole, and that's what you see in these two jets that are coming out the top and the bottom of the black hole. So the dark disk is the stuff that's orbiting the black hole, and then the jets are things that have kind of come in too fast, and so they just get shot back out the black hole.
Wow. So is this an artist impression? Or,
yes.
Right.
Yes.
It's incredibly beautiful, isn't it?
Yes. Yes. I mean, some of you might have seen in April time, the Event Horizon Telescope released an image of a black hole, and you saw that disk structure there. So that was all the stuff that's kind of orbiting the black hole. We can see it emitting.
So not fallen in yet.
Yeah.
So just going around, but then lots of stuff is going in.
Yes.
Except the bits are going too fast, and then they shoot out.
Yes.
Okay.
Yes.
Wow.
And so that is the very center, or an artist impression of the very center of Andromeda, and that concludes our tour.
Okay. Well, let me just go, if we can we go backwards?
Yeah. So yes.
So that bit was in the center.
Yes, right in the center.
Okay. Great. Right, well, I am going to stop the share now and open up the floor to our schools so we can get properly interactive. We need to be just conscious that one school can only type and one school can speak, so that we share the floor. But I'm just going to open it up. Have we got any, let's start with questions about Andromeda first. So that's the big, massive galaxy she's showing us that orbits the supermassive black hole. Have we got any questions about Andromeda? So I'll go to you first, Mr. Hobbs.
Just stand up and come to the front. Nice big voice.
Right, sorry, we can't hear that. We can hear you're speaking, but we just can't make it out.
Is there any sign of life in Andromeda?
Any sign of life in Andromeda?
That's a good question. Not that I've heard of, not that we found yet, no. I mean, the likelihood is that there probably are, there's definitely planets within Andromeda, and there is a possibility that life will have evolved. So it takes quite a while for the sort of information from Andromeda, the light that we see, to travel to us. So it could be that they're kind of sending hellos and we're just having to wait for them, but not that I've heard of yet.
Okay. So
there's a high possibility.
we have another question. Thank you for that. How was it created? I'm assuming Andromeda. And how long ago?
Ooh, wow. These are good questions. So Andromeda was created sort of, if you imagine you've just got a cloud of gas, and under gravity, it will slowly collapse.
Right.
And so if you've got a relatively small cloud of gas, that will create a star, because that's one thing, and with maybe some planets going around it.
Yeah.
If you've got a massive cloud of gas, that will split up into sort of smaller bits that form stars, but those stars will all be sort of bound within the Andromeda. So it's just a big cloud of gas, basically. And then slowly those dwarf galaxies that I mentioned as well, they'll fall onto Andromeda. So it will start collecting miniature galaxies as well into itself, to sort of build itself up. But yeah, a big cloud of gas.
Okay, so that's how it was created. That's a very hard, I like that question for Eve. Challenge her. How long ago was that, Eve?
Ooh, that would have been, I feel around say 10 billion years ago.
10 billion, so quite a long time ago.
Yes, a long time ago. Yes.
Okay. Excellent. Well done. I'm impressed with those answers. So back to Mr. Hobbs. Have you got another question for us? Nice, lovely, loud voices, please.
If a human wanted to go to Andromeda from Earth, how long would it take?
Oh, this is where I definitely should have looked up distances more when I was talking about Andromeda. So to put it into context, sort of, if you were traveling at the speed of light, the nearest star would take 4 years to get to. This is not the sun, the nearest.
So the speed of light is very, very fast.
Yes.
So if I was traveling as fast as I possibly could go, it's going to take me 4 years to get to the nearest star.
Yes. So to get to Andromeda, we're talking millions of years.
Million.
Yeah. Yes.
Millions.
I think, yes.
Gosh,
yes.
Millions of years.
A long time.
And so my question, Eve, was going to be, have we been? You've answered that, because people cannot travel for millions of years at the speed of light.
No.
So no, nobody's been to Andromeda.
Yeah. Fingers crossed we figure out a way.
Yeah, in the future.
Not yet,
no. Okay, so we've got another question. When will the star eventually burn out? So which star is this, do we think?
I mean, so the sun, as I say, is about halfway through its life, so it's been around for about 4 million years, I want to say. No, billion years. Yeah, billion years. So another.
Yeah.
So that's 4 with, I want to say 9 zeros.
Yeah.
Years. And so it's got about another 4 billion years to go, and then it will sort of puff up into a bit of a bigger but cooler star, and after that it'll kind of, those outer layers will sort of float away, because it can't kind of contain itself anymore, and the sort of core of the sun will then just slowly cool in the emptiness of space, kind of forever. So I would say give us another 8 billion years, and then the sun will start to not be sun anymore.
And all different stars, because there's loads of stars in Andromeda. It'll be all different time spans, but all of the region of billions and millions, or is there any ones that are quite quick? Still going to be years, but
I think the shortest, it's still on billions of years, but it would just be a couple of billion years before it exploded.
Just a couple of billion years instead of 8.
So, yeah.
Okay, great. Right, back then to Mr. Hobbs.
How do you know it takes millions of years to get to Andromeda?
How do we know that it's a million years? Yeah.
I guess we've managed to measure the speed of light using, I'm trying to think, the first time we measured the speed of light was using Jupiter, and that's a whole nother story that I can tell you at some other point, I'm sure. So what we've measured the speed of light, and then we also sort of therefore can, what we have done, speed is distance divided by time.
They might have. Can I help you? Can I help you? So we had this question yesterday, and yeah, so I don't know. I don't know from speaking to another space scientist. That is maths. Maths is the reason we know. So we can take all the things we do know, and then Eve said she loved maths at school. Maths is in a lot of physics and astrophysics. So we take everything we do know, and then we make a theory. So we use that maths to kind of work it out. So we can see the light coming from Andromeda. We know how fast that light is traveling from other experiments, and we can mathematically get that estimation. So yeah, that's not exactly how we do it, but it's maths and theory, and then it's the scientist's job to test as much of that out. But obviously, we're not going to know everything because we can't send Eve on a million-year journey to Andromeda. Right. I hope that answered it. I'm no expert, by the way, but that's kind of what cropped up yesterday. Yeah. So from the other school, thank you. Why is it called Andromeda?
Ooh, I think Andromeda is an ancient Greek name. So I've got a feeling it was the ancient Greeks called it that. So for instance, our own galaxy, when you look at it in the night sky in a very dark place like the Brecon Beacons or somewhere, you see it as kind of just a milky streak across the sky, and that's why it's called the Milky Way. So that's where that name comes from. Andromeda is, I believe, another one of the Greek gods. So I think they just sort of named it as that's a celestial being, that's something in the sky.
So the Greeks could see it without any technology. Okay. I'm so
see it as kind of a fuzzy blob.
Yeah.
Yes.
Great. So let's take one more question each on Andromeda and stars and black hole, and then we'll move on to kind of your career, if that's all right. Yeah. So over to you, Mr. Hobbs. Have you got a question for us?
Will Andromeda ever die?
Oh,
well, so this is the fun bit about Andromeda and the Milky Way is that in billions of years' time, I think it's kind of way after the sun has died, so a few billion years, the Milky Way and Andromeda will actually collide and merge with each other. So at that point, Andromeda and the Milky Way will have died and will become a whole new galaxy that will be probably more kind of, it will just be like a big, the bulge of Andromeda, it will just be like a big galaxy like that, a big sphere of kind of red stars will probably be the end point of the Milky Way and Andromeda. So yeah, give it a couple of billion years and the night sky will have changed.
Yeah. Okay. Hopefully that made sense. All right, yeah, we've got another one. How often are black holes created, and then how often are we discovering them?
Oh, this is a good one. So
great questions, by the way, to both schools. I'm impressed.
New black holes being made. I mean, because they take a while to be made. I think supernova go off. So it's within, say, the Milky Way. So within our galaxy and Andromeda, there's a supernova explosion at least every like 10 or so years, I think it is. So yeah, a new black hole, say every 5-10 years. And then discoveries of black holes, the sort of the smaller ones that are made every 10 years or so. If we're lucky and we see the explosion that makes the black hole, because it's that supernova explosion that makes the black hole, then again, yeah, it's every sort of 5-10 years. The super massive ones that I'm discovering, well, I measured one, I discovered one, I guess, this year, and sort of say 2 every year for the supermassive ones. Now
you discovered one yourself this year?
Yes.
Did you get
the realization is like, yes, I did. Yeah.
Did you get to give it a name?
No, we don't get to name things. I mean, yeah, a lot of, well, most things in the sky just have very boring kind of numbers, depending on sort of when they're discovered or which catalogue they're in.
Okay.
So yeah, no, we don't get to name things.
Okay. Sad. Oh my gosh, she's discovered a black hole. Right, so now I'm going to change the slant of the questioning slightly. to just Eve and her career and science and her life. So I will just carry on with the same format. I'm going to go to Mr Hobbs and then back to Mr Jones's class. So Mr Hobbs, have you got any questions? Oh, they're thinking.
How long did you study about the night sky? How long did you study at university?
Ooh, that's nice. So far I have done 7 years at university. So you do the first 3 years, give me what's called a bachelor's degree, and that's like the standard undergraduate sort of degree that everyone can do. Then I did a year which gives me what's called a master's degree, so that's an extra year, kind of a little bit less of the teaching sort of lifestyle that you're used to, and a bit more into the research, like being active, going into the labs kind of thing. And then I've done 3 years of my PhD. So,
could you just what is a, so she's 3 years into her PhD. How long is a PhD?
Normally maximum of 4 years.
Yeah. Okay. So nearly finished your PhD, but what is that?
So that is, you have sort of 3 years to do kind of a new piece of science. So like I discovered the black hole, and hopefully I'll do some more science this year, discover another one, or
she's just going to discover another one.
So casual. And then you write it up into kind of a small book at the end, and somebody from another university reads that and then comes and kind of questions you on it and make sure that it was you that did all the research and make sure that it's a new piece of science that's kind of interesting. And
then you'd be Dr. Eve North.
Yes.
So not a medical doctor, you wouldn't go and see her if you've got an issue, but she would be a doctor of an area of astrophysics. Okay, thank you. That was a great question. So it's 7 years. So but she also would have done high school and then college and then done her 7 years at university. Okay, so Mr Jones' class said, when did you start being interested in all things space?
I guess it was kind of in secondary school, so your age plus like 2 years or so. And that was when I first kind of started looking up at the night sky. And also my parents sort of started watching with me. There's a BBC programme, The Sky at Night, and that sort of really got me interested. And I also got a telescope which helped, because I was able to actually look at things like the Crab Nebula and like Andromeda, or Jupiter, and see its moons and things like that.
So they bought you a telescope?
Yes.
What was it, a large one, small one?
Fairly small one, just quite kind of long thin telescope, but decent enough to look at the planets and some of the bigger kind of things.
Exciting.
So,
right, Mr Hobbs, what would you like to ask now your class?
What's the most amazing thing you've discovered and why?
That I personally have discovered. I feel like it perhaps is, the black hole, the supermassive black hole. So it's a galaxy that's kind of quite far away, but it was a really nice, very obvious within the data you could spot that there was a black hole.
So were you looking at a picture, or when you say data, were you looking at what were you looking at when you went, oh my god, I found one?
It was an image. So I work with radio data, but what we kind of, instead of sitting there listening to a radio hold, we can put it through a computer and that can make an image of what you're seeing. So it was looking at an image that had could tell us.
And so what did you do to celebrate that?
The people in my office have got very into like party hooters, so I think we had a good toot on the party hooter, so it's like a weird thing that we do.
Right.
So I think that was about it, and treat myself to a meal out probably, I think.
Oh, lovely. Right, so next question. Do you think Mars will be habitable, so able to live on, in the near future?
I really hope so. Yeah, I think we could do it. I mean, it will be tough because at the moment, kind of, if we went there, we would all have to wear spacesuits and live in kind of big bubbles and things like that. But yeah, I think it's doable. There's some, as I say, there's some couple of issues that we've got to work out. So Earth is quite lucky in that it's very protected from the radiation within space. So we'd have to make sure that Mars was also equally protected, or the astronauts there were protected from the radiation, but also able to breathe, because Mars doesn't have a very good atmosphere. So we'd have to. Yes, I think we could do it. I think it'd be fun. Yeah. It'd be fun. I mean, personally, I'd love to go to Mars.
Would you?
Awesome,
Yeah, I'm not bothered. I like Earth.
I mean, Earth is awesome.
Okay.
It's fun.
Right. Well, we're getting to the end of our questions now, but let's do 2 more from Mr. Hobbs and 2 more from Mr. Jones, and then I've got one final question, and then we can just say thank you to everybody. So, Mr. Hobbs, what's your next question?
Have you ever considered not having the job you have right now?
Ooh, that is a good question. And to be honest, yes, it is tough, and particularly sort of carrying on, like after becoming a doctor, I could sort of carry on in research, but it means sort of there's a lot of pressure. It means moving about a lot because you want to go and sort of visit other people and see what they found out about the universe. So there'll be a lot of moving around, and there's a lot of pressure to sort of keep discovering new things, sort of so that you can keep getting new jobs. So I have considered other jobs, and also in some ways sort of me thinking about, like at the moment my head is in the stars and I look outwards a lot, but it'd be also quite fun to sort of do something that's more down to earth, and looking at sort of helping the planet kind of thing.
Right. So I was just going to say, what
yeah.
is the other job? So it might be something with the environment.
Yes, would be my sort of thing.
Okay.
Yes.
Right, thank you for that. Are all of the planets named after Greek gods, and why?
So the why is probably just because the Greeks were one of the first people to look up and write down kind of what they saw. So there are Arabic and also Chinese sort of ancient scripts that talk about the planets and things like that, and they do have other names, but the Greeks is the one, I guess, that influenced Britain and the sort of old scientific community a lot. So that's why a lot of them do have Greek names. Some of them are also Roman names. So yes, but then I think as well, when people have, even in modern times, when they've discovered something new, they'll often use a Greek or Roman name just because it kind of fits in with the rest of the names that they've got going on. Like when we've discovered a new planet within, or well, a new large rock within our solar system, we'll probably name it Greek or Roman just because that fits in with the rest of them. So yeah, I think it's just they were lucky that they were the first to write it down.
One day they will probably run out of Roman and Greek gods.
Yes.
Yeah. Okay. Right. Last question from Mr. Hobbs' class is,
how do we know so much about Andromeda when it's so far away?
Oh, how do we know so much about Andromeda when it is so many millions of light years away?
I guess we're very lucky in that nature in a lot of ways is very kind to us and has given us sort of many ways to look at the night sky. So for instance, most of the images that I showed you mostly were optical, so the same stuff that you see with your eyes, the standard light, but we can look at the heat, we can look at the radio waves that things emit, so and the X-rays and things like that. So we're very lucky in that the different processes that go on within Andromeda emit in lots of different sort of types of light, and therefore we've got a lot of kind of information coming at us.
So we can't go there, but we can see it with X-ray pictures, infrared pictures, normal sight pictures, because you said we could go and look at it in the night sky, but we can use that to just put it all together and make theories and assumptions.
Yes, and scientists are very good at sort of sitting there and looking at what they see and coming up with what might at the time seem kind of mad ideas about what's going on. but then we can test it with new observations. So, you know, like say we're like looking at a black hole, I might have gone, okay, that looks really high energy, and then I need to go away, look at the X-rays and go, oh yes, that is actually high energy stuff, and that is what's going on. So we're quite good at thinking of mad ideas, as I'm sure you guys are too. So.
Okay, right, last question from Mr. Jones's class. Oh no, sorry, no, yep, they haven't written one, but you have got one more question if you'd like. So I will move on to my question to finish us off. You can still write yours in there, Mr. Jones. What are you excited about in the future? What is in the future for scientist Eve?
For me specifically?
Yeah, well,
I mean,
yeah, either or.
So I guess, so at the moment I've discovered my black hole and I'm starting with some new data. So I'm quite excited about what that new data is going to tell me, and what I can find out about the universe, which will be kind of like the last bit within my PhD that I'll then write up into my book. I'm excited about what that will tell me. Excited then to decide what job I want to do after my PhD. In terms of overall science, I think it's what excites me most. So at the moment, scientists have a basic kind of theory for how the whole universe works, like what it's all made of. But there's some slight problems that we're not quite sure how to fix. So I guess I'm excited for somebody figuring out actually how the whole universe works, what it exactly is made of. Because like we've got a theory about what different particles there are, but it doesn't quite fit together. So
it's so much more to find out, isn't it?
Yeah.
You can't help but be excited about it. Right, okay. Oh, we've got one more question. Thank you. Do you think there is life on other planets or galaxies? So you said not likely on Andromeda, didn't you? But what about other aliens?
Other aliens
or life on other planets?
I think there probably is, yes. Yes, I think there is life on other planets. Probably, I mean, in terms of like intelligent life that we could communicate with, not within our solar system, I wouldn't have said, unless it's very different from humans, but definitely kind of out there in the universe, yes, within the Milky Way or further on. There might be sort of on some of the moons around Jupiter and things, there might be kind of small microbes and things, which would be quite interesting to find out. I think that
would just be crazy if only the Earth had, when there's so much out there. Yeah, no, it's fascinating.
The likelihood is, it's developed elsewhere as well. So.
Right, I think we will draw it to a close, and that has been some amazing questions. I hope you've enjoyed yourself.
Yes, thank you, it's been wonderful.
I have, and so I commit to all of you right now, I'm going to go and look to Andromeda. Oh, but you didn't tell us how to. So if we all go and do something tonight, and we look, well, maybe not tonight, when it's a nice night, how should we find Andromeda?
Okie dokie, and find Andromeda. So I think this is testing my astronomer skills, because I must admit, as a PhD student, you get quite lazy
because you're looking down at your computer.
Yes, and the telescope, like in Chile, it knows where to point. Like, you know, I select a source and it knows where to point, as opposed to me having to find the source in the night sky. But I think it's so. Look up, you'll see the main big kind of milky light streak of the Milky Way, and it's not too far from that, and it will be quite a big kind of elongated fuzzy blob. So if you can check on the internet, or if maybe an app on like an adult's phone, and you can find there's a constellation of Andromeda that's kind of sort of like some stars like this, kind of in a hoop like that, and it's kind of just above those.
Right.
Is I guess the best.
Okay. I will look and see if I can find it. Right. Thank you so much for coming, students. Sad I can't see you, but I know you're super organised, because the questions have come in absolutely perfectly. You couldn't have wanted better behaviour from both the schools that have attended today, so that's brilliant. Eve, can they find you on Twitter?
Yes, they can.
Yes, I'm not going to ask her what that is, because I can see she might not know, but I will send it on email. So if you've got any follow-up questions, you can send, because obviously 120 of you in one classroom, you might have questions that have gone unanswered. So I'll send you that on email and you can tweet them. And yeah, it's been a pleasure to have you on our Spacelink webinar today. I hope you've enjoyed it. I'll be immediately in touch by email just to say thank you and to gather feedback of how it's worked, how we can be better in the future. But for now, I think you'll have to clap by text writing the North Wales School, but if the Bristol School could give Eve a lovely round of applause, that would be brilliant. So thank you very much, Eve. You sound so many of you. And a text has come in saying thank you very much for calling us at your school first call. So that's lovely. And we're really pleased you came today and that we could speak to you. And I hope, like, obviously some of that was really hard and you might not remember it all, but hopefully it inspires you all to go out and just have a look. And when you're looking at those stars sync, you could have a career in that if that's what you wanted to do. So yes, I'm going to draw this to a close. Thank you so very much again to Eve and to all of you. And we'll send you the link when it goes up on YouTube as well. So thank you very much. And last day of term tomorrow, or maybe today even. So I hope you all have a lovely, lovely summer holiday. Thank you very much.
Thank you very much, both of you. We're really sorry that we couldn't get the video working, but hopefully we can
Well, tomorrow in the future, we'll sort it all out.
Brilliant. Say a big thank you once more to Becky and Eve.
Thank you, Becky and Eve.
That was wonderful. Thank you very much. Take care. Good luck with the research, Eve.
Thank you.
Yeah. Okay, I'll speak to you on email, teachers. Thank you very much.
We're waving you goodbye. Bye.
We're waving you. Bye. Bye, year school class call.